Hello and welcome to SudoKanard. We're here to solve this puzzle from the Happy New Year 2025 contest by Tyler Chen. This was a remarkable contest, and some of the puzzles were very hard, and this is one of them. This one combines the rules of Kira Sudoku and Exam Sudoku. So let's just have a look at the rules. Whenever you have such a cage with a dashed outline, it contains different numbers, only different numbers. No number can be repeated in such a cage. And the number in the corner is the sum of all numbers. So this 25 could be the sum of, let's say, 5 here and 20 there. I don't think this is what happens in the puzzle, but that's an example. And this 44 could be a 1 here and 43 here. But I don't think this is what is happening there again. So that's the rule, and it means that there must be big numbers in those outer cells, and those numbers are X-sum clues, and then X-sum clue is the sum of the first few digits, and how many digits are taken into account in the sum is the first digit that you encounter when looking from this side. So we could imagine that this is 5, and this would be 20, and 20 would be the sum of the first 5 digits. And that is the rule of that puzzle. You can see that there's a stunning visual with 24 here and 25 there. Oops, a 2 and a 5 with the cages. And there are very few clues, and some of them are frightening. 80, 44, 25. What's going on there? And during the contest, I just passed on the puzzle, thinking there was no way I would be able to solve it. And when I looked at the puzzle after the contest, not only could I solve it, but I was absolutely blown away by the brilliance of the construction. So I just hope I'll be able to repeat the feat. And let's start. So a place to start is this very small total for this cage. Something that has to be appreciated about X-sum is that some sums are not possible. Namely, the sum 2 is not a possibility because the smallest sum is a 1. If you take into account only one digit, and this digit being 1, the sum is 1. So 1 is a possibility. But if you put a 2 here, then the minimum value of the sum is 2 plus 1, which is 3. So 2 is not a valid sum for an X-sum clue, so that this 6 cage can only be 1 plus 5. And 1 will be achieved by a single digit 1, here or there, and 5 will be achieved by a single digit 2, and 5 will be the sum 2 plus 3, so that there will be a 3 here. And if my memory does not betray me, does not fail me, this will be resolved at the very end. Or I may be wrong, but pretty far into the solve. That's the place to start, and then where is the next place to start? Well, I think it is here. 25 means that here we have some digits between 3 and 9, obviously. And this is the complement to 25, which is a rather high total. But some totals are very high. For example, if you put 9, then the overall sum is 45, which does not fit here. 45, it will make a total of 54, which is much higher than 25. And actually, if you are used to such number puzzles, and by this I mean Sudoku with mathematical variants, you must have references like a 6 here would provide a sum of at least 6 digits, and the minimum sum you can make with 6 digits is 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. So with a 6 here, the minimum value here would be 21, which is too much, which goes bust for this towards this total of 25. So this has a maximum of 5. This is from 3, 4, 5. And let's just ponder all those options. So there's a lot to work on. Let's try 3 here. I said 3. In this case, this has to be 22, which means that those 2 digits here must sum to 19. That doesn't work. So that 3 is not an option here. Let's try 4. If this is 4, then the sum has to be 21, which means that those 4 digits here sum to 21. That's 17 for that. And this becomes a 7. And that seems to work. So 4 seems to be a valid option with a 7 there. So let's just try with 5. If I put 5 in here, then this clue here, this x-sum clue is 20, which means that the sum of those 4 digits must be 15. In which case, the sum of those 3 digits is at most 14, and this is at least 10, which is not permitted in this very Sudoku because I didn't state it, but this puzzle follows the rules of Sudoku. So that 5 is not an option either, and this case of 4 here is the right one with a 7 there, 3 digits summing to 17. And this sum here is 21. So that is brilliant in itself. 17 here, 17 there, which sum to 34. With 4, that's 38. We know that the sum of all 9 digits is 45, so that those 2 digits must sum to 7 without using the 4, so they must be 1 and 6 or 2 and 5. So that's a lot of pencil marking, but this is not your typical Sudoku puzzle on the channel, so I have to use some unusually heavy pencil marking. Let's recall that 7 is not repeated in this cage, so that 7 must be somewhere in this cage. We haven't tackled the subject of digit 3. 3 can't be in this cage because 7 plus 3 is 10, and the third digit would have to be a repeated 7. So 3 is somewhere around here. That's a total of 10. We need another 14, which will be with 8, 6 or 9, 5, and which one will be determined by whether this is 1 and 6 or 5 and 6. And at this point, it doesn't seem to be resolvable. Actually, 1 could be excluded, but this is not the right moment to discuss this clue. Let's move on to these other totals. What about this? This one is not 1, 2, 3, 4, so this is at least 5. Could it be more? Could it be a 6? If this is a 6, then we know again that the sum of 6 digits is at least 21, so this is at least 21, plus 6, this is at least 27, and this is at most 1. It doesn't work. So 6 is too much, and 7, 8, and 9 will be too much by the same argument, so that this has to be a 5. Now, what about this? Well, 6 doesn't work for the same reason. If this is 6, then this is at least 21, which is already too much. So only 3 is a possibility here. So the sum of those 3 digits plus this is 26. So those digits must be rather high, or this total is rather low. Let's just ponder the options. If I try to put a 9 here, if I try to put a 9 here, and this is 12, so that this is 14, and 14 works with a 2 there. So that's a possibility. I will just register the possibilities here. Let's try with 8. With 8 here, that's 11, so the sum here must be 15, which works with a 4 there. So 8 here and 4 there is an option. 7 is not available. Let's try with 6. That's 9, so this has to be 17, and 17 works with an 8 there. So this says a lot can happen here. 9 with 2, 8 with 4, 6 with 8, and I think that 5 is too low. Oops. If I try a 5 here, that's 8, so we need 18, and this must be 10. So this doesn't work, but we still have 3 options in here, which is a lot. But now let's have a look at this row. We're still in need of 6, 7, 8, 9, and you can see that 7 is in none of those 2 cells. And we get a 6, 8, 9 triple, which means that we need those 3 digits to fit in those cells, so that those 3 digits are not available for the rest of the block. Another way of saying this is that we need to place 1, 2, 4, and 5 in those 4 cells, so that 8 doesn't belong in here, and 8 was associated with 6. With that, we know that 6 is somewhere in here, so we can exclude 6 from those. And we need 1, 2, 4, and 5 in those cells. This is probably unnecessarily heavy pencil marking. So where do I look now? I could look more to 28, or perhaps this. No, rather 28, I think. This 80 clue can be addressed as well. But let's begin with 28. What comes here? So 4 seems to work. If I put 4, then this must be 19, and those 3 digits must sum to 10, which is a possibility. We could have 7, 1, and 2, for example. So 4 is definitely an option. Let's try 6. If I put 6 here, then this is 17, which means that those 3 cells must sum to 6, so that this must be from 1 to 3, but none of them is available. So 6 doesn't work, 7 is not available, then 8 is too much. With 8, this would have to be 15, and we already have 13. Those 3 cells would have to sum to 2, which is absolutely impossible. So that is 4. The sum here is 19. And those 3 digits must sum to 10. Let's ponder the decompositions of 10 as the sum of 3 digits. 1, 2, 7, 1, 3, 6, 1, 4, 5, 2, 3, 5. So those 3 digits must be one of those, and obviously those are impossible. So we need 1, 2, 7 or 1, 3, 6, so that this is 6 or 7, and those are from 1 to 3. And this is in the same cage as this 3, so this can't be a 3. Let's have a look at this cage. This cage has a total of 35, and it has 6 digits, which means that the missing 3 digits sum to 10. And this list is relevant again. The missing 3 digits here must be from one of those lists. We know that 3 is not a missing digit, so that those 2 can be removed. And we know that we must have at least 1 digit from 1 and 2, so that the list of missing digits can't be 1, 2, 7. So the missing digits in this cage are 1, 4, and 5. This is one of my favorite pieces of logic in the puzzle. So that 1 is the missing digit here. This is 2. And now the only way of achieving 10 is with 7 here and 1 there. Beautiful. And I just deleted 1, 4, and 5, but 1, 4, and 5 are the missing digits here, so that the right digits are 2, 3, 6, 7, 8, 9. So that's the composition of this. We already know that digits in this area are 3, 6, 8, 9, but that 3 are in this area. So the remaining digits here are this digit here, which must appear in the cage, and the only place it can appear in the cage is here, and a 7 there. All right, nice. So this 19th part is resolved now. And this is not a 4, by the way. Let's have a look at this part. We need 3, 6, 8, and 9. And this has strong restriction on what is happening here. If I try to take at least 6 digits into my sum, well, those 6 digits will sum to 45 minus those. That is 29. So we must have at least 29 here. That doesn't work. So only 3 digits will be taken into account into this sum. And let's just see all the possibilities. If this is 6, if this is 6, then this becomes 17, and it works with an 8. So 6 here works with an 8 there. If I try 8, then 3 plus 8 is 11, so this has to be 15, in which case this would have to be a 4. That doesn't work. If I try so 8 was here. If I try 9 here, that's 12, so this has to be 14, and this has to be a 2. That doesn't work. So the only option is with 6 here, 8 there, and 9 here, and this is a 3 because of this 2 clue, and this here, 9, this is 70. So a lot has happened in this area. And our next place of interest is this 80 cage. So we know that the sum of those 2 digits must be 80, which means that the sum of the first few digits in here and the first few digits in there, how many remains to be determined, the sum of all these digits is 80, which means that the digits on the other end, the outliers, must sum to 10. Why 10? Because the sum of all digits in those 2 columns is 90, so the outliers sum to 10. So we must see how the outliers here will sum to 10. And there are actually several ways of doing this. One way of doing this is to have a 3 here, a 6 there, and a 1 there. So that would work. It would mean taking 8 digits in this part and 7 digits in here. So with 8 digits here, 3, 7 digits here, we exclude 6 and 1, that would work. But another possibility would be to take all 9 digits in this column and then taking something here that sum to 10, that would work with 8 and 2, with 9 and 1, and no option with 3 digits would work. So in both cases, this is a 7, and this is never a 5. So the options would be 3, 6, 1, 9, 1, 8, 1. I think this is correct. An interesting point is this 8-9 pair in here. Now, what are the options for this 9 cage? We know that 3 plus 6 is not an option, and that 8 plus 1 is not an option. So the remaining options are 4 plus 5 and 2 plus 7. And what's nice about this is that we have a virtual 2-4 pair. The 2 digits from 2 and 4 are both in these three cells. Yes. One is here, the other one is in there. So that this is never a 2 or a 4, so that this 6 cage is with 1 plus 5. This is not a 5 and this is not a 4. And we see that 6 is somewhere here together with some digits by there. This 8 must be somewhere in the column. It could be here, it could be there. By the way, there is a 3 here, so this is never a 3. So where is the next place to look? Can something more be done about all of this? Perhaps, but I'm not seeing it, so I think it's time to move on to this column. Oh, this one here is not there. And so that this is not 6, let's recall that those 2 digits sum to 7. And actually here, 1 here wouldn't work either. So why would it work? If this were a 1, then this x sum clue would be a 1. This would be 43. And 43 could only be achieved by summing 8 digits here and having 2 as an outlier, which is definitely not the case here. So for this reason, 1 here doesn't work, and this is not 6. So after all, 2 and 5 are excluded from there. And what about a 2 here? If I try to put a 2 here, well, a lot can happen. A lot can still happen. So this digit here is never a 1, it's not a 2, it's not a 3, it's not a 4, it's not a 5, it's not a 6. Oh, that's interesting. This digit here is from 7, 8, 9. Well, it could be 7, 8. Actually, 8 is never in this cage, because with 7 and 8, the third digit would have to be a 2. Oh, that is cool. 8 is not in this cage, which means that 8 is in this cage, And this case is with 7, 8, 3, and 6. So this is from 6 and 8, and those are 3, 6, 8, and those are 7, 9, and 1. That's correct. So 1 or 7 here, 1, 7 or 9. So what about the possible sums here? If this is 5, then we take those 5 digits and they sum to 24, which means that this is 20. That is good. What about 2 here? If 2 is here, then the sum here will be either 9 or 11. Let's try 9. It means that this is 35. And yes, 35 doesn't work. So how do we make 35 as the sum of the first few digits? It means that the outliers at the other end sum to 10. Actually, 10 would seem to work with the 6 there, 7, 1, and 2. Oh, I don't remember having that much happening. By the way, those are from 1, 2, and 5. I will cancel out that. So actually, 9 here seems to work with 2 and 7. All right. What about 2 and 9? If I put 2 and 9 here, and this is 11, this has to be 33, and it means that the outliers here must sum to 12. 7 is not available, so that would have to be a 6, with 3 digits summing to 12. And 8, 1, and 3 would work. Wow. I didn't remember that so many cases had to be studied. My guess at this moment is that I overlooked some of them when I solved it after the contest. Right? So 2 and 5 seem to work. What about the value here? We saw with the examples I just mentioned that this had to be a 6. In case this is a 2, then this has to be a 6. If this is a 5, then this sum is 20, and I know that this is what happens in the end. This is 24. 24 could be the sum of 6 digits or 5 digits. 5 is not available, so it would be 6 digits. So 24 as it could also be the sum of 4 digits. 24 could be the sum of 4 digits. 4, 5, 7, 8. I don't think this can be excluded. All right, so plenty of options on this spot again. So where do we go from here? Perhaps one of them just doesn't work. Oh yes, one of them here doesn't work. Let's recall that 8 is with the 4 and 9 is with the 2. Yes, that is correct. When I considered the possibilities for that, 9 was with the 2 and 8 was with the 4, which means that 8 and 2 are not in here together. There's always exactly one of digits 8 and 2. And when I mentioned the options about the outliers for this 80 clue, one of the options was with 8 and 2 here. The others were 3, 6, 1 and 9, 1. But 8 and 2 here is impossible. It would pair a 9 with the 4, which is not an option. So I can remove the option of 8 and 2 here. That's 1. So that 1 is somewhere here. Does it help? Perhaps we should have a look at what is happening here. Oh, but already something is happening. 5 here, 1 there. So what goes there? So one option is with 9 and 2, in which case we get 5 here, 4 there, 8 here. And this is 6 and 7. 6 and 7. Oops. So I'm just saying at what is happening. If I take 9 and 2, all seems to work pretty well. And that's a 6, and that works. So is it that 8 and 4 do not work? If I try 8, 4, let's say 8 here, 4 there, then this is a 9, in which case this has to be a 9, and this has to be a 6. With the 4 there, this has to be a 2, 7 pair, and this is a 6, 5 pair. And I don't think there's any problem with this option. Bobbins. Unless I'm missing something, which is totally possible. Is there something about this? By the way, 9 is not here. So this is not 9, but that doesn't appear to be very useful. Let's ponder this 9 gauge. We already know that it's not with 3 and 6, but that's the only option that seems to be excluded. Perhaps we should have a look at this 48 gauge. 48 is quite a lot. Yes, those 3 digits have a max. Oh, those 3 digits do not include a 9. So the maximum value here is with 6, 7, 8, which is 21, which means that this is at least 27. We don't know the exact value, but this here is at least 27. And on the other hand, the minimum value here is with 6, so the maximum value here is 42. Actually not 42, because 42 would require the outlier to sum to 3, and the outliers sum to at least 7. So the maximum value here is 38. And I'm not sure that what I just wrote, oh yes, it appears on the screen. This video is already very long, but I think that the puzzle deserves it. So the sum here, the clue here is between 27 and 38. So the amount of digits could be as high as 8 with a 7 there, but it can't go below 6. So this is either 6 or 8. So how could it work? Eight here would really mean a 7 there. If we can decide on this, for example, 8 would resolve that, 6 would resolve that. So 8 is the more promising option. If I put 8 here, then this is either 7 or 9, which means that this is either 36 or 38. Oh, yes, oh. So if I try to put an 8 here, let's say 8, then this becomes 36 or 38, in which case those two sum to either 44 or 46, and those two must sum to either 2 or 4. 2 is not possible, and 4 is not possible. It would have to be 1 and 3, and 1 is not available. So 8 here doesn't work. This is a 6, and this is 4. Which means that this is not that much. And I think that this excludes the 2 here, because 2 here would say that this is either 9 or 11, so that would be either 35 or 33, none of which are doable with the 4. So I can remove those. So finally, this is a 5, that is a 2. The sum here is 24. The sum here is 20. Which means that the sum of those 3 digits must be 16. How are we achieving that? Is it a question for now? Or perhaps we could just see that this 9 cage does not include the 2, does not include the 3, so it's either 1 plus 8 or 4 plus 5. 4 is not here, 5 is not there. That is still not that promising. Perhaps there's something about this cage. Now we know we take the sum of the first 6 digits, which means that those 3 digits are outliers. There are lots of values for this. So we already said that the minimum value here is 27. So the minimum sum here is 33, which means that the maximum sum here is 15, which is not a strong restriction, if you ask me. Well, perhaps this is the more promising way of looking at things. So 3 digits summing to 16. Would 1 work? 1 would come with another 15, which would be 7 and 8. 6 is not available. 7 and 8. So we would have 1 here, 7 there, 8 there, 9, 1, 7, 8. Oh no, 7 and 9 here. No, I put a 9, it's an 8. So 9 here, 1 there, 7 there, 8 there, 1 here, 2 and 3 here. That seems to be worth exploring, but I'm looking for something that breaks. Nothing seems to break at this point. So 1 here seems to work. Let's just make ourselves content with something that just breaks. What about 5? 5, 4, we need another 11 without using 5, 4, or 6. So that's 2, 9, or 3, 8. That's a lot of possibilities. What about 8? What about 8 in here? Those two now must sum to 8 without using 5 or 6, so they must be 1 and 7, and that clashes with that. All right, so 8 here is not an option. Good news. So that this is not 1. So let's just assume this is good news. So with the 1, let's just write it down. With 1, we said that this would have to be 7, this would have to be 8. What about the case where this is 5? If this is 5, then those two must sum to 11, which are either 8 and 3 or 2 and 9. With 3, 8. 3, 8 would be similar to that. And with 2 and 1, this would be 7. Oh, what am I looking for? Oh, sorry about that. With 5 here, this becomes a 2. So that 2 and 9 is not available. That has to be 3 and 8 in this option. So in all cases, this is an 8. So that this is not 8. So 1 here turns this into a 7. And 5 here turns this into a 3. I think this is correct. Yes, we have 12 here. We need another 8, so that's either 1, 7 or 5 and 3. All right. So we already have 14. This plus that must be 34. And what are the options for this digit? We know that 9 is somewhere here. 1 is not available, so I think 2, 3, and 7 are the values. So with all those values, 14, 34, so the values for this are 34 minus that, which are 32, 31, and 27. So oh, let's just do Sudoku. There's a 2 in here, so that this is a 5, this is a 2. Yes. So now, now what? So we have more information about the outliers in here. We know that the sum of those three digits is either 13, 14, or 18. So how could 18 work? It will require those two digits to sum to 13. 7 and 6 is not possible. 8 and 5 is not possible. 9 and 4. 9 and 4 would work. So that's the option with 7 here. 9, 4, 8. But 1 would be here and there. I think what I said is true. If I try a 7 here, 21, that is 27, so those must sum to 18, which only works with 9 and 4, with the 1 here, and 1 here. So 4 here would make an 8 here and a 1 there, which would clash with this one. So that doesn't work. 7 is not welcome into this cell. And actually, there was probably another way of seeing this. So 7 is not welcome here. So this is either 31 or 32, which means that the sum here is either 13 or 14, with a 5 here. The sum here is either 8 or 9, which means that 9 is not welcome here, and that this has to be a 1. Wow. And that this has to be a 1, so that this is 7 and this is 9. This is from 2, 3, and 7. So there is a 7 here. This is not 7. This is not 7. So the only option is with 5 here and 4 there. This is now 1. This is now 8. With a 7 up there, 9 here, 6 here, 8 there, 9 here. 9 would come with the 2, which just adds up with all of that. This is 8. And this is really the case where we took 1, 6, and 3 to sum to 10. We can find the numbers here. 45 minus 7 is 38. 45 minus 3 is 42. And by the way, the sum here is 13, which means that the total sum is with 32. 32, 40, 46, this has to be a 2. And this is a 3, and this is a 7. This is all falling into place. That is 4, that is 5. This is a 6, 7 pair with 6 here, 7 there. This is 8. 9 goes here. This is 8. This is 8. This is 3, 6, and 3. Now all approximately all of the clues now are satisfied after all this struggle. So only the Sudoku part has to be done, except for this. We know that 2 and 3 will be in line, so we'll see how this goes. Here we need 2, 4, and 6. So 2 is here, 4 and 6. Those are 5 and 3. Here we need 1, 2, and 9. So this is 9, this is 1, 2. Ah, yes. So we shall need something. 3 goes there. This is 4 and 7, so 4 here, 7 there. 6, 4. 3 and 6, and 3 goes with the 2. That's a 1, 2 and 1. And we can fill in those clues. That's a 5, that's a 1. And by the way, this is 14. And let's just finish the solve by the rules of Sudoku. I don't think I need to explain what I'm doing right now. 2 here, 6 there, 1, 4, 8, 9, 5, 4, 6, and 9, and it works. Sigh of relief. All right. I solved it much faster during the, no, not during the contest, but after the contest. But that is just because I overlooked some of the cases. I remember thinking, oh, this 48 clue is not needed. It was needed, after all. So that is an incredible construction by Chen, a very hard one. And I was probably right in not attempting the puzzle during the contest. It would have taken too much time, or actually I didn't have enough time anyway. So that's not the typical solve on the channel. My videos are much shorter usually, but from time to time I can somewhat emulate what cracking the cryptic does. Thanks for watching this, and see you soon on SudoKanard with Sudoku Grand Prix.